Okay, hi dosto. Very good afternoon. So today we are going to start our new series that would be going to cater all the. Sorry for that. And okay, it will be going for like data structure and algorithms. Okay, so here it is not like I'm not going to start from very beginning, like defining everything variable and all, and then going to the searching, sorting, and all other algorithms. Okay, graph algorithms or tree based algorithms. So what I will concentrate, I will take one topic, I will like explore entire part of it, and like you will get all whole understanding of it. Okay, so and like in the chunks we will complete one part of entire thing. Suppose like if I take the sorting, so I will complete entire sorting series first, then suppose searching, then tree, then graph. These kind of like we will complete in this way. Okay, so I think guys, let's start, and we today, let's see what we have today. And yeah, so we have sorting. Okay. So let's go through this, like what all this like the sorting algorithms will we will going to cater. And here if you see, so I have, I think, included almost all the sorting. And yeah guys, so here I will be explaining the background of it, how it is working, like the entire logic behind it, and then definitely we will implement it. Okay. Okay. So so there will be like kind of two parts. One part is for this only the understanding, then like the continues to this. Part two will be so for their implementation. Okay, so let's start, and let's start with, I think it is bubble sort. Yeah, so bubble sort. Okay. Okay, so guys, there are a few things that we like have to keep in mind with respect to bubble sort. Okay, so actually it has first is kind of like it it works on the pass thing. Okay, so pass is means like, and in one pass, like there are like whatever the, suppose you got any array. Okay, so in that, right, so if you want to traverse to uh, entire of your array, then in that case, like you have to traverse like one element by one element, right? So to traversing entire thing, that is called one pass. Okay, so I will explaining what happens in one pass. Okay, so and the other thing is like at during this one pass, you will be going to continuously compare two of the elements, and then like if they are kind of uh, what in bubble sort does is like kind of wherever the in the entire list at in one pass, whichever has the highest value, like the most like the maximum value of that, it will be going to throw out of the into the right of it. Okay, and the second, and so now you got it right. In one pass, the comparison swapping will be happening continuously, and like swapping, like it will be going to first compare. If it is already sorted, then it will not going to swap. If it is short, it sorry, if it is not sorted, then it is going to be swapped, and if it is sorted, then there will be no swapping happen. Okay, so and the second part that it includes is like kind of so in like in each pass, maximum number uh, going to be, that's I already mentioned, right, it will be going to be the rightmost, and it will kind of throw out like the it will put the maximum number to of that array to the rightest of it. Okay, and the next part is kind of so each time, guys, so like generally we use any loop, right? So here if you see, so each time the what the number of the comparison going to be happen, it is p, you can like the formula you can use like n minus 1 and minus of I. So like in the let me give you example. Okay, so suppose I have pass 0, so I have suppose this as a element. Okay, so as you can see, there is 7 elements. So now what the zero pass means here is like, first I will be going to like the take a loop, and like it will be going from 1 to 9, right? And there I have to compare all these values. Okay, only two values at a time going to be get compared. Suppose this is the first two comparison will happen. So now if it is if it is kind of not sorted, or suppose 4 was before this and 1 was like the after 4, so it would, like in that condition, it will be do the comparison and it will swap that. If it is like already sorted, it will do not, it will not do anything. Okay, so it will going to then again check for the next one. And okay, so now here it is also sorted kind of thing. So likewise it will be going to be like entire this way, it will be going to, now from here to, it will be going to like just let me, okay, now next time it will be going to compare this one and this one, and next time it will be going to compare this and this one. So now guys, here if you see, so 31 and 17 going to get compared, and here if you see, like 31 is bigger than this, right, 17. So now it will going to like uh, so it is not sorted, so it will going to be get swapped. Okay, so 31 going to get swapped, then again here is this part will be 31 will come, right, instead of 17. So 31 again going to get compared with 21, again it will be going to swap, right, and it will be 31 going to go like in the place of 21, and 21 going to in the place of uh, like if you just let me, so it will be, the expression will be kind of, here it will become 17, here it will become 31, then here it will be 21, right. Now if you swap, so it will be 21 will come here and 31 here. So now again 31 will get compared with 9, right. So now if you see, so this the last expression you will get this. So it is in one pass, as you guys you can see, like it is the one pass. It is like entire, if you're traversing to entire array, this is called one pass. Okay, so in one pass, as you can see, so I have seven elements. Okay, so how many number of comparison you can possible comparison have happen. Okay, so if you see this is one, between 1 and 4, then 4 and 12 2, and 12 and 31 3, 31 and 17 4, and sorry, and 17 to 21 5, and 20 like 31 and 9, it is kind of 6, right. So if you see, so it is, this is the like the formula. So as generally like in the like the whatever the code you write, it will be going to be start with the 0, right. So that's why here it is written the 7 minus 1 minus of I is 0, so it is going to be only 6 times. Okay, so yeah, so this is the first pass. So suppose, so this is the final. So now if you see, so I have 7 elements, only 6 comparison happens. So guys, as you can see, so 31 is already sorted, so we next time we do not need to compare 31 with their in other values, right. So it is because it is already sorted. Now what we will do, so next time our loop will be kind of going to be, now from 7 minus 1 only till 6 it will go. Okay, from 0 to 0 1 2 3. So okay, so suppose it is 0 1 2 3 4 5, right. So it will be go from 0 to 5 only. So and so comparison will be going to be 1, then 2 3 4 and 5 comparison is going to be happen. Okay guys, so yeah, so now each time if you see the passes going to get increased, the number of comparison going to be lower and lower, and it will at last it will be going to only one comparison. Okay, now let's move to the next part. So suppose in pass one, what will be happening, so it will be kind of, earlier it was like the formula n minus 1 minus of I, right. So I will become 1, so 7 minus 1 and minus I is equal to 1. So it will be 7 minus 2 is equal to 9. Now there will be 5 comparisons. Okay, so it will be like 1 2 3 and then 4, then yeah, the last comparison will be with them, and it will be, you will be getting this sorted. Like if you can see, like the two elements are like here they are sorted, right. Now like next part will be like the past 3, and it will be going to have the similar trend, guys, and it like all the things are similar. So why I have kept it like so that you can understand. So if you got this point, so during your logic you can, okay, you know that, okay, so I have to have one loop that will each time traverse, like they're going to be traverse entire thing, and there will I have to have another loop also. So another loop going to be responsible for generally the swapping and comparison and swapping. Okay, and how many comparison and how, like the each time you have to reduce the comparison size also. So in that part we will like it will be going to be happen. Okay, so as you can see, so there will be only 4 comparisons, and again the other things, if you see the arrays last 3, like I have highlighted into yellow part. Okay guys, so it is kind of sorted. So next part next like the in pass, it was past. Okay, so now it is pass 3. So in pass 3, if you see only 3 comparisons should happen, and yeah, so if you see, so it will between them it will be going to get passed. Okay, so if you see, so almost the array is like the sorted. Okay, so if you see, so this is already sorted now, but still what happens, the going comparison going to get happen. Okay, so yeah, so this is the one of the challenge that bubble sort has, like it is not, you can say, adaptive. Okay, so adaptive here means like it is directly like at the time when it is suppose find the already sorted array, so it will not going to get triggered. Okay, it is already sorted by default. Okay right, but there is a way like you can use that amend that like logic, like you have to have one flag. It will be going to only just check if it is like swapped or not. If it is or not, like kind of not swapped, like there is no swapping happened, so we can say that okay, it is already started kind of thing. Okay guys, but by default it is not there. You have to have make that amendment. Okay, so here if in the next pass is value going to be 2 comparisons only. So again you can see this, and now in the last there will be only one swiping, one comparison, and if it is, so it will be going to swiping also. So you, as you can see, one comparison, so now you got all the sorted array. So guys, if you see the complexity, if you see complexity wise, at each time what happens, so first time it got n minus 1 comparison, right? Next time it got n minus 2 comparisons, and likewise n minus 3, and then it reaches still one comparison, right? So if you see, this is the like this is the like the total number of complexity what happens. So with respect to that, if you see, so if you write this expression n minus 1 into n minus 2 n minus 3, likewise if you write till 1, it will become like is, you know that there is a formula, right? So natural sum of natural number n minus 1 n into n minus 1 divided by 2. So if you see total, it is kind of n square minus n divided by 2. So as you know that this is that we can directly like write it to into it like kind of O of n square, right? So here O of n square means here is like the worst case complexity I'm telling you. Okay, worst case scenario, big O of n square. So yeah guys, there are yeah, like like the possibility of that, like if you it can be like on order also. If the array is already sorted, then we can say like, but still we, because it is not adaptive, we have to have like we have to have a flag using which we can say that okay, if any in one in past one, suppose any swapping not happened, then in the in that case we can say that okay, it is already sorted, and at that time you guys, as you know that, right, it will be only having n minus 1 possible comparisons, right? So now if you I say like eventually we can say that it is of big O n, right? Okay guys, so let's go to, yeah, so I think this is the things you should have noted down. So here, like generally if you go for the interview, okay, so suppose they ask for the sorting, like the uh, tell me the complexity of the bubble sort. Okay, so yeah, so you in the best case, yeah, that I mentioned, it is kind of for the only the sorted array. Okay guys, so sorted array, so like as I already have mentioned guys, right, it is not adaptive. You have to externally take care of it. Okay, so if it is already sorted, then we have to switch off it, then you will get at the possible n minus 1 comparison. So n minus 1 comparison going to be eventually big O of n complexity, right? So this is the best case scenario. If it is like in worst case scenario, like all the arrays is jumbled up, so it is in this. So like each time all the comparison will happen, it will be going to like the n minus one passes will going to be happen, and so likewise it will be going to be in order of n into n minus 1 possible comparison and divided by 2, so it will be eventually n square, big of O n square, right? And with respect to average, so average is going to be, average here means like guys, so suppose in the previous example as you see, so at some point we got this or sorted array itself, right? So even in that time also, even we whatever we have got, though like if you write an expression, okay, so master theorem, if we write that, so we generally get the in the order of n square root, okay. So that's where it is, like you can say it is average is also like of n square order, okay. Yeah, okay guys, so here if you see the next part is kind of space complexity, right? So sorry, so in space complexity means like how many variables you are going to have it, okay. So suppose I have an array, so that is going to be the other part, but the in our whatever the logic you have written, how many variables you are going to use that. So generally like for the swapping you can use temp, right? Temp variable be used for the swapping. uh, so this is you can say order of like one. Yeah, there is possibility of it will, if we the other part that I mentioned, suppose it is I write this one flag swap, and if it is right true, so in this case it will become uh, the like the space complexity will come to O of 2 like this, okay. So now next part is like, yeah, so one part is with respect to stability, okay. So what is the meaning of stability? So stability means here if you see this example, okay, so 1 4 1 1, okay. So suppose if shorting happens in one pass itself, it will be going to, you will be going to get the this is this array, okay, the sorted array. But here if you see, so whatever the one, where have it been, it has the same order, okay. Earlier it was as 0 position, here it was actually it was at 1, it was 2, it was 3, right? So even if you see, so it has become 1 itself already, and this one become at, sorry, so this has to come to now 1. So earlier it was at 0, okay, sorry, 0, and it is 1, and this one for, and now get 2, and this one become 3, right? But if you see here, so suppose if I say it have been uh, if I say it is 1 dash 1 double dash, right? So their order always going to be in the same, 1 dash 1 double dash, right? So if you see, so all those even if you do the sorting, so their orders are same. Again the one at here, the in the first array whatever the position they have, okay. So guys here you don't have to think of the as a position wise, okay, 0 1 2 or 3. So you have to think like, suppose one is, this one is unique, okay, and this one is unique, and this one is also unique. So now even if you do the changes, so it has not jumbled up to, it has not come to again like the order had not changed with this, right? So this is the called the maintenance of order, okay. So that's what, so it is kind of, you can say the stable. So at the if you like, you know the location of any element of it, you can directly access that, so you will get the same kind of like you will be have the confidence of having this the element you are targeting, okay. Another part that I already mentioned, guys, it is not adaptive, but it need to be created to become an adaptive, okay. So adaptive, I think you guys have got it right, what adaptive means. So if suppose at some place whatever the array have become in between, suppose at some place it has got sorted already, but the algorithm will not going to stop there, it will still continue to compare and all, okay. So yeah, at that point if we have something like I will show guys into the coding, so exactly you will get that. So it will be kind of one flag that will get triggered once any no comparisons happen. So we can say that, okay, now the our uh, like the array is already sorted, so we can move on, okay. And so next part is going here it is going, as you can see, so bubbles the complexity related thing. So okay, why it should be and where it should be used. Okay, so the complexity, the whatever the development you are doing, and if it doesn't matter to the complexity of this. Okay, so, and it is very simple, as you know that it is kind of very simple, any like the layman person can understand how it is happening. Okay guys, I think yeah, that is it for the theory part. Yeah, let's move to the next part to develop the code of it. Okay guys, okay, thank you so much and see you in the coding part. Okay.